Hey everyone, it's Weston with Outside Science Inside Parks.
Graphic reads Outside Science Inside Parks.
National parks preserve some of the most amazing landscapes in the country. In this episode, Park Science helps NASA learn about other amazing landscapes on other planets. Check it out.
Quick cuts showing cave exploration, mineral sampling, and sample preparation. Speaker is Darlene Kim, a research scientist at NASA Ames Research Center.
We have an incredibly multidisciplinary team out here. And when I say multidisciplinary, I mean that there are people from all walks of life who have integrated themselves to answer questions relevant to how does craters of the moon actually help us understand the moon, Mars, asteroids, and so forth in our solar system.
Speaker is Alexandra Mathieu-Novak, a planetary scientist at Johns Hopkins University.
Craters of the moon is a fantastic analog for volcanic processes that happen on other planetary surfaces, including the moon, Mars, Venus, and Mercury.
Speaker is Brent Gary, a geologist at NASA's Goddard Space Flight Center.
And that's why, NASA and our teams keep coming back here to study, because it gives us a ground truth and a reality check for what else is out there in the solar system.
Speaker is Raymond Francis, a NASA scientific applications software engineer.
There's a big team out here from NASA and several other institutions, and we're doing a group of connected studies trying to compare this terrain that we see here to the kinds of fresh lava flows we see on the surface of other planets and on the moon. My work at JPL is half in operating robots to explore the solar system and half in teaching those robots to be more autonomous. And so I've brought a system out here that we've developed which allows autonomous classification of geological scenes. We already have some systems like this that are already working on Mars. This is a new, even more advanced scene classifier that we've tested on Earth, that we've demonstrated on a satellite, and that we're hoping to get into a future rover mission for Mars.
Speaker is Sarah Johnson of Georgetown University.
We're collecting samples of this white powdery deposit, and we're putting them into these tubes, which we're going to add to a cryo shipper, and that sort of stops time.
The reason we're interested in that is because we're kind of astrobiologists, and we're interested in the idea of life on Mars and how we might detect traces of life on Mars. And in this Mars-relevant environment, we were looking down into these lava tubes to try to find these minerals, and we're testing them to see if microbes are having an influence in the actual precipitation of these minerals.
Speaker is Andrea Jones, an education specialist at NASA's Goddard Space Flight Center.
So right now we're in a lava tube, which is a place that lava once flowed through this spot and actually left it. So when lava is flowing, it's hot on the outside and hot on the inside, but it cools faster on the outside, forms a crust, and then you can sometimes get lava moving all the way through, and you're left with this open spot.
You want to know how irregular the topography is.
LiDAR is essentially using a laser beam, and that laser beam goes out and hits the rock surfaces and then comes back to the detector, and by calculating the time it takes for that laser beam to hit the rock surface and come back, we can tell the distance from that rock surface to the LiDAR scanner, and then we're able to put together a three-dimensional model of whatever we're scanning.
Speaker is again Brent Gary.
I've never mapped lava tubes in 3D before, so this gives us a new dimension on looking at the morphology of these lava tubes and the textures that are preserved.
Speaker is Matt Daniel, a National Park Service education specialist.
And I think that's one of the more interesting things about national parks. They serve as these intact ecosystems which can act as living laboratories for people to come out and use, learn from, and accomplish real science. Anybody from NASA all the way down to the middle school teacher that's with us today.
Speaker is Angela Latona, a middle school teacher.
I think it's a really great experience for me to have firsthand, so that when I'm back in the classroom I can really talk to my students about how science is messy, and it's not some movie scene aha moment where the discovery is made. It's a lot of debate, it's a lot of getting down and dirty, ripped clothing, dirty hair, and just sort of getting into the, into the cave and looking at it firsthand.
Speaker is again Brent Gary.
It's tough work crawling through a lava tube all day. Somebody's got to do it, but that's part of the science, and it's slow going, it's tedious at times, or monotonous even.
Speaker is again Andrea Jones.
A lot of people do think of the scientists in the white lab coats working by themselves, but science is dirty, science is fun, science is creative, and it's teamwork.
Speaker is again Raymond Francis.
It's very important to understand the world that we live on and We live on a planet, and if you want to understand planets, you have to study all of them. Because it's much easier to come here, and as difficult as it can be to walk across these flows, than to go to Mars or the Moon.
Still shot of a starry sky.
Visit craters of the Moon, fly to Mars, definitely craters of the Moon. Thanks for watching Outside Science Inside Parks. Join us next month when we paddle down the Green River in Dinosaur National Monument.
Graphic reads, thanks for watching. Don't miss next webisode, Taking the Pulse of a Wild River in Dinosaur National Monument.